Good morning. So we will continue with our discussion on Newton's laws and dynamics. So last time we have defined or differentiated kinematics and dynamics. So kinematics describes the motion of an object by answering the following questions, while dynamics it answers why is the object moving in a certain way or what causes the object to change its velocity. So we also defined force as the interaction or the push or pull of one object to another object or to its environment. Force is a vector quantity and it has an SI unit of Newton. So if two or more forces are acting on the object, then the total force can be calculated using vectors addition. So you have the net force or the sum of all the forces acting on a system is just equal to F1 plus F2 plus F3 and so on. So forces can be classified into two. We have the contact forces, wherein these forces results from physical contact between two objects. And we have field forces, or these are action at a distance forces, wherein even though there is no direct contact with each other, okay, so it can act at a distance. So we have several kinds of forces, but in mechanics we will encounter these forces: gravitational, normal, frictional, tension, centripetal, and buoyant force. We also have discussed Newton's laws of motion. So we have the law of inertia, the law of acceleration, and the law of interaction. Okay, so let us get acquainted with the free body diagram. So it is abbreviated as FBD. It is a diagram showing all the forces acting on a body. So we use the free body diagram to illustrate all the forces acting on a body. So uh, with the free body diagram, the forces acting on a body can be resolved into components. Kung naa kay isa ka system, that will correspond to one free body diagram. If you have another system, you have to illustrate its free body diagram separately. Okay, so for example, you have an object in equilibrium condition. So this object is, say for example, a box that is sitting on a table. Okay, so there are two forces acting on the object. We know that the weight of the object is one, or the gravitational force, and then the other one is the normal force, that is the support force uh, exerted by the table towards the box. So we can make a free body diagram out of this. So you have this one. So these are just vector representation of the forces in the Cartesian coordinate system. Okay, so this is the free body diagram of the box and the object. Okay, so this is the free body diagram of the box, the system, the box and table system. So we can call it a system. So we have the normal force going upward. You have it is along the positive y-axis, and then we have the weight or the gravitational force that is going southward. Okay, here comes another system. So it is an accelerating object. So this one is an object that is in equilibrium. And then this one is another box and it is accelerating. So it is moving to the right with this applied force. This one also is considered to be a rough surface. So suppose this is a rough surface, then you have frictional force. So you have four forces acting on the object. The applied force going to the right, and we know that frictional force is an antagonistic force. So it is always opposite to the direction of motion of the object. So padulong siya sa left. Then the normal force is perpendicular to the surface that the box is in contact with, and the weight is always directed southward. So we can also add here acceleration, the direction of acceleration. Okay, so we can add in the free body diagram uh, the direction of acceleration. All right, here comes another surface, and the same box is in it. It is accelerating towards this direction. How many forces are acting on this? There are four. So you have the normal force, the gravitational force. We have the frictional force. Okay. So this tulo lang kay wala siya applied force. Take note that the normal force is always perpendicular to the surface. So you have this one, the normal force. This is your surface. So take note that we have made the surface as the x-axis so that our normal force is directed perpendicular, parallel, or it is coinciding the positive y-axis. And then take note that uh, the gravitational force is always directed downwards regardless of the surface. And then, since the object is moving or is accelerating down the incline, so the frictional force is going there. Okay, so it is opposite to the direction of motion. Okay, so the x and y axis of the free body diagram can be rotated for convenience. So in the case of an inclined plane, we can rotate the x and y axis. So let us define the normal force. So the normal force denoted by the Greek letter N. Okay, so the normal force is the support force exerted by a surface to any object that it is in contact with. So for example, you have an object on a level surface. Okay, so we have here the normal force and the weight of the object acting on this particular object here. Okay, so if we are going to add the forces, we will have forces along the y only. So you have sum of forces along the y is equal to force 1 plus force 2. So our force 1 is the normal force, which is positive. So we write the normal force here. And then plus another force that is the gravitational force going downwards. So you have a negative sign. So this is why we need to illustrate all the forces acting on an object through the free body diagram so that we can easily visualize the forces. Okay, so you have a negative sign here. That is because the gravitational force is southwards as seen in the free body diagram. Okay, now since this system is in equilibrium, it means it is not moving or it is moving at constant speed, then the sum or the net force should be equal to 0. So you have 0 is equal to the normal force minus the weight or the gravitational force. And then manipulating this, we just have to um, transpose this to the other side of the equation. And then we get the normal force is just equal to the weight. So now the weight of an object or the gravitational force can be obtained using uh, this. So you just have to multiply the mass of this object. So if the mass is given, you have to multiply it with the acceleration due to gravity. So for a level surface, you have the normal force is equal to mass multiplied by the acceleration due to gravity. Now, if you have an inclined surface, you have here the normal force is always perpendicular to the surface. So as you can see, the normal force is this one. And then your gravitational force is always southward, regardless of the orientation of the surface. Okay, so we have here the free body diagram. So this is our x-axis, and then this one is our y-axis. Okay, so for this, na kay angle theta, the surface is inclined by an angle theta. Now, take note that if that is theta, if this angle here is theta, or if the angle of inclination is theta, then this angle here is also equal to theta. Okay? So the normal force and the weight are the forces acting on this object. Okay, so this particular system has forces acting on the x-axis and forces acting on the y-axis. Okay, so for forces along the y, the net force is equal to 0. So you have this one. F sub y is equal to the normal force minus the y component. So we have here the y component of the weight. So nasa diri, y component of the weight. And then the weight also has an x component that is going to the right. Okay, so natay component of force along the y and component of force along the x. Okay, so notice that this side is adjacent to the angle theta. Therefore, you have 0 is equal to the normal force minus W sub y, or the y component of the gravitational force. And then manipulating this, we have the normal force is equal to W sub y. Okay, now your W sub y is equal to mg cosine theta, because again, this particular side here, your W sub y is adjacent to your angle theta. Okay, so this is the normal force for an inclined surface. Now, how about the frictional force? We have two types of forces. We have learned that frictional force is an antagonistic force. It always resists the motion of an object, and it is present in any rough surface. Okay, so if the problem says that the surface that an object is in contact with is rough, then automatically there is frictional force. But if it says the surface is smooth, then we can disregard friction. Okay, so for smooth surfaces, friction is minimal or zero. Okay, so we have two types of frictional force. We have static friction, and then we have the kinetic friction. Okay, so static friction is the frictional force that keeps the object from moving. If the object does not move, even there is a force applied to it, this is because the frictional force is much greater. Okay, so we have the the static friction. Static friction is less than or equal to mu sub s times the normal force. Okay, less than or equal to mu sub s multiplied by the normal force. So take note, class, that uh, static friction is the force that you need to overcome in order for the object to move. So the applied force should be greater than the frictional force or the static friction in order for it to move. Okay, so take note that mu sub s here is the coefficient of static friction. And then kinetic friction is the frictional force acting on the object when it is in motion. So the object is in motion, but there is an opposing force which is less than the applied force. Okay, so you have F sub k is equal to mu sub k multiplied by the normal force. So we have um, mu sub k here is the coefficient of kinetic friction. Alright, and then we have the tension force denoted by capital letter T. So it is um, the force that is associated with a rope, cord, cable, string, and the like to whatever it holds. Okay, so take note that the tension force is always directed along the length of the cord and away from the object. So we have two players here of tug of war, and then they are pulling the rope. So we have two forces here. The force F1, which is directed away from player 1. So notice the red arrow, it is going away from this player. And then we have the second force, this blue force here. We call this F sub 2. So this is the tension force that is exerted by the rope on the player, on this player, player number 2. So it is directed away from player number 2. Take note that these two forces are equal in magnitude, but as you can see, they are opposite in direction. Okay, so let us differentiate mass and weight. So mass is an innate property of a material. So it is the measure of the amount of inertia. It is in kilograms. So your mass here on Earth is the same as your mass in any other planets or in the moon, for example. So mass is an innate property of matter, while weight is the pull of Earth's gravity on any object with mass. Weight is also known as the gravitational force. It is measured in Newton. And this force, the gravitational force, is what makes the object accelerate downward. So matingala ka, tanang object nga imong buhian kay mahulog yun. Or ikaw kung moamba ka anong downwards man gyud padulong. Okay? So that is because of the gravitational force. So it makes the body or any object accelerate downward. So the magnitude of weight is equal to this one, mass times the acceleration due to gravity. So if you have an apple sitting on a table, then the earth is actually pulling the apple. So F earth on apple, and this one also, your ceiling fan suspended in the ceiling, on the ceiling. The earth also is acting on it. So gravitational force is an action at a distance force or a field force or a non-contact force.